All right, today we're going to start 6.4% of increase and decrease. Please take out your red pens, and I want you to write down this formula in your notes. So today we're going to be talking about percent of change. Here's the formula. It means amount of increase or decrease divided by the original amount. If you would, just take your pencil, and I want you to draw a cloud around this. This is going to be the abbreviated version of that longer formula. P, or the percent, equals AOC. Does anyone think you might know what AOC stands for? What do you think, Tacoby?
Amount of change.
Amount of change, very good. So you're going to take the amount of change and divide it by the original amount. So everyone say AOC.
AOC.
Divided by original. All right, so we're going to use that formula to help us on our problems today. This asks us to find the percent of change as an increase or a decrease and round to the nearest 10th percent. So as you can see here, there was a little tiny Christmas tree. It started off at how many inches? 10 inches. And then at the end, it was how many inches? 25 inches. Guys, do you think that that tree increased or decreased in size? It did increase in size. So we're going to start off by writing our formula. If everyone would write this down, please. AOC, the amount of change, divided by the original amount. In order to find the amount of change, you are simply going to take the bigger number, 25, and subtract the smaller number, 10. So let's write this down. In order to find the amount of change, 25 minus 10. Divided by the original amount. How tall was that tree originally when we planted it in the ground?
10 inches.
10 inches. Maddie, what's 25 minus 10? 15. Is there any number that can go into a 15 that can also go into a 10?
Yeah.
What number?
5.
5. So 15 divided by 5 is? 3. 10 divided by 5 is? 2. Okay, so I've got 3 over 2. I would like to turn this into a decimal. How do I turn 3 over 2 into a decimal? Divide. Guys, what is 3 divided by 2? 1.5. Now, if I go back to the original question, it says to find the percent. I need to change 1.5 into a percent. Does anyone remember how to change 1.5 to a percent? What do I do, Jace? Not to the left, to the right. 1, 2. Okay? And then I'm going to drop in a little egg into that egg carton, and what do you get, Jace?
150%.
Very good, 150%. Now remind me again, class, did this tree increase in size or decrease in size? It increased. That means it got bigger or it got taller over time. So there was a 150% increase in size. All right? If that tree increased by 100%, that means it would increase by itself, okay? So if it increased only 100%, it would be 10 plus itself 10. It would have grown 20 inches. But in this case, it increased more than just 100%. It increased 150%, all right? Let's go to the next one, problem B. Let's imagine that I throw a big math party. And at the beginning of the math party, 65 people were there. But 2 hours later, some people had to leave. And how many people do you think were left? 57 people. I want to find the amount of change. What percent of people had to leave 2 hours later? So let's start with our formula. Repeat after me. AOC.
AOC.
Repeat after me. AOC.
AOC.
Divided by original. Very good. Now, Seer, how do I find the amount of change? How do I find it? I'm going to have to subtract. What numbers will I be subtracting?
57 and 65.
Okay, very good. So 65 minus 57. Divided by the original amount. Reagan, how many people were originally at the party?
65.
Very good. What should I do next, Jocelyn?
Then you would see what goes into both of them.
No? Who can help her out? What should I do? Reagan.
Subtract.
Subtract. What's 65 minus 57?
8.
8. So now I have 8 65ths. What do I do, guys?
You divide.
I'm going to divide. Put that in your calculators. What is 8 divided by 65? Raise your hand once you've got it. What'd you get, Jace?
0.123.
Okay, very good. Now I want to change that decimal to a percent. Ellie, how do I do that? Two places to the right. Okay, so now my decimal point has been moved there, and I'm left with 12.307. Okay, and it did keep going on. Guys, which one of these is the tenths place? The 3. Okay, so remember, this is the tenths. So I'm going to take that number right there. That's the number I want to round it to. And he's going to ask his neighbor right next door to him, are you 5 or bigger? What does that 0 say? No. So does the 12.3 stay the same, or does it get bigger? It's going to stay the same. So I've got a 12.3%. Did the amount of people at my party increase or decrease? It decreased by the end of the night. All right, for this next problem, you can see I have some little giraffes, okay? So when this first giraffe was born, how tall was he? 8 feet. Did the giraffe stay at 8 feet? No, he grew bigger. To what size? 24 feet, okay? So did it double in size? At least? Okay, so we know it's at least going to be bigger than 100% because it got bigger by doubling itself. Okay, so let's do it the way that we've been working through the problem so far. What is the formula for amount of change, class? The amount of change divided by the original amount. Abigail, how do I find the amount of change?
You have to subtract 24 minus 8.
Very good. You take the bigger number and subtract the smaller number. And Abigail, how big was this giraffe originally?
8 feet.
8 feet. All right. Luke, help me out. What do I do next?
You subtract the 8 and 24,
Okay, what do you get?
and you get 16 over 8, and then you divide that, and you get 2.
All right. Now, guys, would it make sense for me to say it increased 2%? No, 2% is a very dinky amount. This giraffe went from 8 feet, it doubled and then doubled again to get to 24 feet. So 2% doesn't really make sense. So what do you think I have to do with that 2? Jonathan? Okay, here's what I want you to remember. Guys, let's say that I went around and I found $2. Do you understand that this right here says $2? Does this also say $2? Yes. So what I want you to think about right now is when I have that 2, I know this is not dollars, but that's 2.00. I have to change that decimal to a percent. How do I change this to a percent? Move the decimal 2 times to the right. When I do that, what's my percent? 200%. Did this giraffe increase or decrease in height? It increased. Now, doesn't that make more sense? If it's going from 8 and then getting bigger and bigger, it is going to be a big increase, 200% increase. All right, let's look at the next problem, number 2. The table shows the number of hours that you spent online last weekend. How many of you guys have ever had it on your phone where it says, like, you averaged this much time per day on your phone? How many of you have ever been mortified at how much time you actually spend on your phone? Yes, I think sometimes it's way too much. So here you can see, on Saturday, how many hours did you spend online?
2 hours.
2 hours. Did you spend more or less time on Sunday? Even more time, 4.5 hours. So here's what it's asking. What is the percent of change in your time spent online from Saturday to Sunday? Michaela, what is the formula we've been using today? Good job. We're going to take the amount of change and divide it by the original amount. Jocelyn, how do I find the amount of change?
You subtract.
You subtract. So we're going to take the bigger number, 4.5, and subtract the smaller number, 2. Class, which day did we originally spend time online? Saturday or Sunday?
Sunday.
Originally. Saturday. How many hours were we on our phones online on Saturday? 2. Maddie, what's 4.5 minus 2? Okay, 2.5 or 2.5 hours. We're going to divide that by the original amount. Guys, what's 2.5 divided by 2? 1.25. What should I do with my decimal point to turn that into a percent? 2 times to the? To the right. What's the answer? 125% increase. Okay, very good, because you increased in the amount of time that you spent online from Saturday to Sunday. All right, we're going to do one more example that looks similar to this. This bar graph here shows a softball player's home run totals. Raise your hand if you've ever played softball or you've ever played baseball. Okay, very good. We are trying to figure out the percent of change from 2016 to 2017. Which years do you see on your graph that we don't need to know for this particular problem? Ellie, what are they? Okay, the top two, 2014 and 2015. So I want you to take your pencils. You can just draw a little X on there. We're going to eliminate that information because it's not asking me anything about 2014 and 2015. Instead, we're going to focus on 2016 and 2017. Okay? All right, we're trying to find the percent of change. Class, what's the percent of change formula? All right, the amount of change divided by the original amount. How do I find the amount of change from 2016 to 2017? Okay, we're going to take the bigger number, 28. In the first year, she made 28 home runs minus 20 home runs the next time. Originally, what was the original amount? 2016 or 2017? 2016, because it came first, all right? How many home runs did she make in 2016? 28, so we're going to divide that by 28. Reagan, what do I do next?
8 divided by 28.
Okay, very good, because he knows 28 minus 20 is 8, and now he's going to tell us what 8 divided by 28 is.
0.2857142.
All right, Reagan, what should I do with that decimal point?
Move it over 2 times.
2 times to the?
Right.
To the right. Okay, so if I were to now rewrite that, I am left with 28.57142. Going back to my original problem, it says round to the nearest what?
110,000.
Whole percent. Looking at this number right here, what is my whole number? 28. Everybody underline the 28. The 28 asks the neighbor right next to him, hey you, are you 5 or bigger? What does the 5 say? Yes. So does the 28 stay the same or does it get 1 bigger? It gets 1 bigger. So what's 1 bigger than 28? 29. Help me out, guys. Did this softball player increase or decrease in the amount of home runs she got?
Increase.
Unfortunately, she had 28 and she went down to 20, so she did decrease. Does it seem like next year, if she does the same thing again, will she be doing great or not so great?
Not so great.
Not so great. It seems like her talent is decreasing. It might be time for her to get out now. All right, so we're going to go on to a new idea now. What I'd like you to do with this new idea is please take out your red pen, and I want you to write down the formula for percent error, and then we'll talk about this in just a minute. Okay, so the next idea is percent error. This is the percent that an estimated amount differs or is different from the actual amount. If you would, take your pencil, and I want you to draw a cloud around this formula. The percent error formula is the amount of error divided by the actual amount that something is supposed to be. So let's look at our first example here. You fill bags with about 16 ounces of homemade dog treats. Let's imagine that you work at a pet shop. What's a pet shop you could work at? Jacoby. Anyone? PetSmart. Okay, that's okay. PetSmart, all right? That's one of them. So let's imagine that you work there. And you have to, by hand, put individual dog treats into the bags, and you only want 16 ounces. The acceptable percent of error when filling a bag is 5%. That's basically, PetSmart is saying, we understand you're not perfect, but we don't want you to put too much in these 16-ounce bags. Why do you think they care you not putting too much in a bag? Jonathan? They don't want to lose the products because in turn, they would lose money. So their goal is to make money, not to lose money, okay? So that's why they don't want too much of an error. Tell whether or not the bag is acceptable. So once again, here's our formula. The percent of error is finding it by finding the amount of error divided by the actual amount it was supposed to be. How do I find the amount of error? If it was supposed to be 16 ounces, but I put in 15 ounces, how do I find the amount of error?
Yeah, you AOC divided by original.
No, this is going to be this right here. I'm finding the amount of error. How do I find the amount of error? Do you guys know what the error would be? If it was supposed to be 16, but I did 15, what's the error?
The error is 1.
It's 1. How'd you get 1? It's 1 down. You subtract it. So take the amount it was supposed to be minus what it actually was. And divide it by the, as it says here, the actual amount it was supposed to be. Guys, how many ounces was it supposed to be? 16 ounces. So divided by 16. Just the girls. What's 16 minus 15? Girls? 1. 1 divided by 16. Boys, help me out. What is 1 divided by 16? It's not 16. That would be 16 divided by 1. Luke, what is it?
0.0625.
0.0625. Jocelyn, I want to change that to a percent. How do I do that?
You go 2 times to the right.
2 times to the right. Jocelyn, what's our answer? 6.25%. Class, would this be acceptable or not acceptable?
Not acceptable.
Why is this not acceptable? Okay, it is more than 5%. It said the greatest error that I could have is 5%, and I went above that. So what do you think PetSmart might do with me? They could fire me, which would be very sad. But here's the deal, guys. Look, I have a bag B, so guess what? They're giving me a second chance. Let's see if I do any better this time around. I want you guys to try this on your own and see if it's acceptable or not acceptable. All right, Jacoby, help me out. What did you and your partner come up with? How do we do this problem?
So we did 16.5 and then to 16. Then we divided it by 16 ounces. Then we got 0.5 over 16. So once you divided that, you get 0.03125. And in order to make it a percentage, we moved it 2 places to the right. And then we got 3.125%. And that wouldn't be acceptable because it's above the amount that we're supposed to have. Wait, no, actually, no. It would be acceptable because it is 3% rather than over 5%. So it would be acceptable.
Okay, very good. It is acceptable, as he says, because it was less than 5% error, okay? So it looks like I saved myself and I am able to keep my job at PetSmart. Woohoo! So listen, tonight's homework is going to be to start working on your midterm review sheet, numbers 1 through 20.